Astronomers have long been on the hunt for something massive, something mysterious, lurking far beyond Neptune. But spotting it is no easy task. It doesn't appear in any images. Instead, its presence is inferred from the way it tugs on the orbits of distant icy bodies. Scientists call it Planet 9, and the search has been going on for years. Yet, in the process of chasing this elusive ninth planet, astronomers recently came across something entirely unexpected, something remarkable. Meet 2017 OEV 201, a newly identified dwarf planet candidate. But it's not just another addition to the roster of distant icy worlds. This object could be hinting at a puzzling truth, something that might challenge the very assumptions that drove the search for Planet 9 in the first place. The discovery was made using observations from the Dark Energy Camera in Chile and the Canada-France-Hawaii telescope. Rather than a lucky snapshot, it emerged from a careful analysis of 7 years' worth of archival data, revealing 19 separate detections, enough to reconstruct its orbit. And once mapped, the orbit turned out to be extreme. 2017 OF 201 traces a long, stretched path around the Sun. At its closest approach, it comes in at about 44.5 astronomical units, just beyond Pluto. But at its farthest, it swings out past 1,600 astronomical units. To put that in perspective, that's more than 50 times the distance to Neptune, and a single orbit takes roughly 25,000 years. That's not just distant, it's deep into the outer Oort Cloud. The object itself is estimated to be around 700 kilometers wide, and perhaps most intriguingly, it doesn't interact with Neptune at all. It simply drifts in the far reaches of the solar system. No one really knows how an orbit like this even came to be. One theory suggests that 2017 OF 2021 might have had a close encounter with something massive, maybe a planet, that hurled it into this elongated trajectory. But in recent years, astronomers noticed something strange. Several distant objects beyond Neptune, called trans-Neptunian objects, TNOs, weren't behaving as expected. Instead of their orbits pointing in random directions, a surprising number of them were lined up similarly. Their paths were clustered, tilted, and stretched roughly the same way. In space, when orbits start behaving like that, it usually signals the influence of a massive, unseen object. One hypothesis proposes a giant planet, somewhere between 5 and 10 times the mass of Earth, disturbing their paths. That's essentially the origin of the Planet 9 theory. Here's the twist, though. 2017 OF 201 doesn't fit this pattern at all. Its orbit is completely misaligned with the others, and that's a problem. If Planet 9 is out there and responsible for the clustering we've observed, then objects like OF 201 shouldn't exist, at least not in a stable orbit like this. In fact, simulations suggest that including Planet 9 in the model would eject OF 201 from the solar system within 100 million years. So we're faced with a puzzle. Either OF 201 is a rare fluke, or the Planet 9 hypothesis needs a serious rethink. And it doesn't end there. 2017 OF 201 spins only about 1% of its orbit close enough to be visible, which means we may have spotted it purely by chance. If that's the case, it could be just the tip of the iceberg, hinting that dozens, maybe even hundreds of similar objects are lurking out there, hidden in the distant reaches of the solar system. Right now, the dwarf planet happens to be relatively close to the Sun from our perspective on Earth. That gives researchers a small window. They'll need to wait about a month or so before follow-up observations can begin. They're also hopeful that they'll eventually get the chance to study it using the James Webb Space Telescope. Until then, the question of Planet 9's existence remains open. Here's why. The simulations that predict the effects of Planet 9 assumed a specific location for the hypothetical planet, but not everyone agrees on where it might be. Konstantin Batygin, one of the scientists who first proposed Planet 9, points out that the discovery of 2017 OF 201 neither confirms nor rules out the planet's existence. Speaking with NBC News, he explained that the objects in the outer solar system most likely to show signs of Planet 9's gravity are ones whose closest approach to the Sun keeps them far enough from Neptune to avoid strong interactions. Unfortunately, OF201 doesn't fit that description. Its orbit is too chaotic. Still, hope isn't lost. Sihao Cheng, who led the discovery of 2017 OF201, says the search for Planet 9 is very much ongoing. The entire project began as a hunt for it. So, if you're holding out for a ninth planet, don't give up just yet. In fact, a team of astronomers at National Tsinghua University in Taiwan may have developed a surprising new approach, potentially bringing us closer than ever to finally finding it. The object itself is likely more massive than Earth, though a bit smaller than Neptune. It occupies that strange middle ground between rocky terrestrial planets and giant icy worlds. Its orbit is nothing like the neat, nearly circular planes of the known planets. Instead, it stretches incredibly wide, about 20 times the distance of Neptune's orbit. And yet, it's just a tiny speck, a faint dot hiding in decades-old telescope data from two sky surveys taken 23 years apart. Still, this faint dot could represent one of the biggest discoveries in modern astronomy. If it truly is what scientists suspect, it might finally be the long-hypothesized Planet 9. But why do astronomers even think Planet 9 exists at all? The story goes back to 1781, when English astronomer William Herschel was scanning the sky with a telescope he built himself. He was searching for comets, but instead stumbled upon an object that didn't behave like a comet. Over time, astronomers realized this new object orbited the Sun steadily, slowly, and at a great distance. They named it Uranus. But further observations revealed something curious. Uranus didn't move exactly as Newton's laws predicted. Its orbit wobbled ever so slightly, but enough to catch astronomers' attention. A French mathematician named Urbain Le Verrier worked out the problem with pencil and paper, suggesting that another unseen planet might be tugging on Uranus. He even calculated where this mystery planet must be. When astronomers pointed their telescopes to that spot, they found Neptune, exactly where the math predicted. Fast forward to 2016. Two Caltech scientists, Mike Brown and Konstantin Batygin, noticed something odd in the orbits of several distant Kuiper Belt objects. These orbits weren't random. They were clustered, tilted in the same direction, as if something massive far beyond Pluto was pulling on them. Following the data led to a staggering possibility. The only way to explain these strange orbits was a hidden planet, a world 5 to 10 times the mass of Earth, orbiting so far out that it might never be seen with visible light. They called it Planet 9. Ever since, astronomers have been chasing it, following faint clues at the far edge of the solar system. The farther away an object is, the harder it is to see, especially if it reflects very little sunlight. To hunt for Planet 9, scientists turned to two infrared sky surveys, one from NASA's IRAS satellite in 1983, and another from Japan's Akari mission between 2006 and 2011. Now comes the clever part. A team led by astronomers at National Tsinghua University in Taiwan looked for objects that appeared in both surveys, but not in the exact same spot. This isn't like tracking a comet streaking across the sky. If Planet 9 exists, it would crawl along at about 3 arc minutes per year. A minuscule shift. To put that in perspective, the full moon spans roughly 1,800 arc minutes. So how do you even notice such a tiny motion? That's where parallax comes in. You know the effect when you hold a finger in front of your face, close one eye, then the other, and your finger seems to jump? Astronomers use the same principle, but on a cosmic scale. By observing the sky from different points in Earth's orbit, they can detect subtle shifts in distant objects' positions. Over time, these shifts reveal how far away an object is and whether it's moving. Using this method, the team searched for objects that stayed in the same place year after year, eliminating parallax, then checked which ones drifted slowly over decades. Eventually, they found something. A faint dot in the IRAS data from 1983, and another dot 47 arc-minutes away in the Akari data from 2006. Could it be the same object? Could it be Planet 9? Possibly. Based on its brightness in the infrared, it would have to be more massive than Neptune.
So what happens next?
If we have a rough idea of where this object was back in 2006, astronomers can try to spot it again with powerful optical telescopes. The challenge is that in the years since Akari detected it, the object would have moved, and we don't know exactly where. Fortunately, we have tools that can help. The dark energy camera in Chile, for example, has a wide enough field of view to scan the region of interest. Soon, the Vera C. Rubin Observatory will come online, offering even deeper and broader surveys of the sky. If this object is real and still faintly glowing, chances are good we'll see it again. Not everyone is convinced, though. Mike Brown, one of the scientists behind the Planet 9 hypothesis, examined the data himself. While he doesn't completely rule it out, he's skeptical. The candidate object's orbit doesn't line up with predictions. Planet 9, if it exists, should have an orbit tilted about 15 to 20 degrees relative to the plane of the solar system. This new object, however, has a tilt closer to 120 degrees. That's not just a tilt, it's orbiting in the opposite direction from most planets. In Brown's words, that doesn't mean the object isn't there, but it almost certainly isn't Planet 9. So what do we make of it? Finding something unusual doesn't automatically mean it's the planet we've been hunting. Either way, one thing is clear. This mysterious dot, Planet 9 or not, is going to keep astronomers busy for years to come.